This short overview will explore the EHR clinical data file provided to you on Service Workbench using R and RStudio. Our goal is to understand the picture exported EHR clinical data structure and help you get started with basic data analysis for your project using R. The variable types in your dataset depend on what you selected to include in your request. Overall, this can include variable types such as demographics, diagnostics, medications, lab results, and procedures for the EHR clinical data file. The picture output format consists of 5 columns. Patient num represents a unique patient identifier. Concept path represents the clinical variable of a given observation. In this row, we can see we are looking at race under the variable type demographics. Tval-char, the text or character value of the clinical variable, if applicable. And val-num, the numerical value of a clinical variable, if applicable. And finally, timestamp, the date and time associated with the given observation. Our first section focuses on demographics. Here, we will explore, organize, and visualize the demographic data available in our dataset. This includes age, sex, and race. These are some examples of what we can do with the dataset in this format. We can demonstrate age distribution by creating a histogram plot or an age group table. We can demonstrate race distribution by table or bar plot. Diagnostic data in our dataset. Diagnostic data in your dataset will be provided in ICD-10 code format. In this case study, we will investigate epilepsy as a disease of interest, represented by the ICD-10 group code G40. In clinical research, it's common to look at multiple conditions at once. This kind of analysis is key when you're interested in comorbidities or overlapping health conditions. Here, we investigated a patient diagnosed with both epilepsy and migraines using a filtering approach that allows us to handle multiple diagnostic codes. For example, we can create a data frame displaying our epilepsy cohort with a column indicating whether each patient also has a migraine diagnosis. This can help us understand the prevalence and serve as a basis for further investigations with other available data on our dataset. In this section, we will investigate the medications administered to our cohort of interest. It is important to note that the data provided in your dataset reflects medications and dosages given to patients at specific dates and times, rather than a list of chronic or daily medications. In this section, we created a list of all medications administered and extracted data on the medications of interest in our epilepsy patient cohort. In this section, we investigate the lab results in our dataset. Just like the medication section, we created a list of all labs available in the dataset. We then demonstrated how to use the dataset to search for specific lab tests of interest and analyze and visualize the results in various ways. For example, by creating a table with summary statistics, or a box plot to graph the distribution of selected lab results, and finally, graphing lab result trends in a single patient over time. Last and not least, we have the procedure section. The procedures are defined by CPT codes. We can create a list of procedures in the dataset, just as we did before with other variables. And in this example, we search for a specific procedure of interest in a given time frame.